This lesson is called Solving One-Step Equations Division. That means we're going to be focusing on one-step equations that have division in them, and I'm trying to figure out how to solve for x, or solve for the letter, the variable, if there's division in the problem. Before we get into that, I want to address something that you have probably learned in the past, but you may need to be reminded of. Fraction times a whole number. How do we multiply a fraction times a whole number? Well, first of all, if you do a fraction times a fraction, like let's say you're going to do 2/3 times 3/4. Okay, so this is fraction times a fraction. You probably remember that you have to multiply straight across. The numerators multiply. 2 times 3 is 6. And then straight across at the bottom, the denominators multiply together. 3 times 4 is 12. So our answer for this 2/3 times 3/4 equals 6/12, which is the same as 1/2 actually. So there's your answer. That's a fraction times a fraction. But what about a fraction times a whole number? So let's try that. So why don't we say this is number 1, and now we're going to do number 2. So number 2 is going to be 2/3 times 5. So how do we do a fraction 2/3 times a whole number 5? It's pretty simple. Any whole number can be made into a fraction very easily by drawing a 1 on the bottom, because 5 over 1 is still the same as 5. 5 divided by 1 is just 5. So the 5 really hasn't changed. We just made it look like a fraction. And now that we can multiply just like we did with the first problem. Straight across the top, the numerators, 2 times 5 is 10, and 3 times 1 is 3. So 10/3, which is an what do you call it? I can't think of the word. The kind of fraction where you have a bigger number in the numerator than the denominator is called a... It'll come to me later. Anyway, that's a perfectly acceptable answer. And now I remember what it is. It's called an improper fraction. But improper fractions are just fine. We can leave the answer just like that if we want to. The reason that we need to know how to do this is because we're going to be using this skill when we're solving the one-step equations. Let me show you, for example, we might be solving a problem where we have to do 6 times x over 6. Now this is a whole number times a fraction. When you have x over 6, that means x divided by 6. It doesn't look like the typical fraction that we're used to, but it is a fraction. And to help us to see that it's a fraction, we can put the 1 in front of the x if we want. Remember, we always said that an x is the same as 1x, right? So we could put the 1 there. And so now we can see this is really 1/6 x, or 1x over 6, but we can read it with the fraction first, 1/6 x times 6. And if we want to multiply those together, what we need to do is we need to make the 6 into a fraction over here. So we draw a line and put a 1 on the bottom. So now we can multiply straight across like we did with the other ones. So we do 6 times 1x, which means we do the 6 times the 1, comes out to 6, and we keep the x. So 6x, and then down here it's 1 times 6, which is 6. And this is the key to why we're going to use this skill. 6 divided by 6 here is 1. So we really end up with 1x, and that's exactly what we're going to want when we're solving the equations. Because when we solve the equations, we need to find out the value of the variable. We need to find out how much is 1x equal to. So being able to get 1x at the end when we multiply is going to be really important. So part B now is solving the equations. Number 1, if I have n over 4 equals 12, I need to draw my train tracks first. And I've done that because I want to remember there's an expression on the left and an expression on the right. My expression on the left is n divided by 4, and that equals 12. So n divided by 4 means I have an n divided into 4 groups. So I've got one n. Let's pretend for a second, let's pretend that this tile represents n. But n divided by 4 means I'm taking this n and I'm dividing it into 4 smaller parts, right? So I just have like 1/4 of an n that I'm talking about here. And that 1/4, that little part of the n, equals 12. But I don't want to know what one little part equals. I want to know what the whole n equals. What does 1 whole n equal? So how can I get 1 whole n instead of n divided by 4? Remember that n over 4 is the same as 1n over 4. So this is 1/4 n. How can I get 1n all alone? Well, the way we do this is we can multiply by 4, because if this is n divided by 4, multiplying by 4 will help us to get 1n. And the way it works is, remember, we have to do 4 over 1 because we want to do fractions multiplied together. So really what we did was took the 1 over 4 and we flipped it over. Put the 4 up top and put the 1 down below. By flipping that fraction, that means taking the reciprocal and then multiplying, it's going to help us to get 1n. Because 4 times 1n, well, let me just write it out here. 4 times 1n is 4n. And 1 times 4 on the bottom is 4. And remember, 4 over 4 equals 1. So that's why flipping this fraction over and multiplying is going to give us 1n. So what we did was we multiplied times 4 over 1. So that means we have to do it on the other side. I have to do times 4 over 1 here as well. Because if you do it on one expression, you have to do it on the other one also. So then that means the 12 needs to have a 1 on the bottom. 12 times 4 is 48. And 1 times 1 on the bottom is just 1. 48 divided by 1 is just 48. So that's all I have. 48 equals 1n, and I can just write it as n. So n equals 48. Can we check to see if that's really true? That n really does equal 48? Let me write the problem again. When we originally wrote this problem, it was n divided by 4 equals 12. So if n really equals 48, we should be able to put 48 in here for n. So I'm going to write it above right here. I'm going to write 48 like that. So if n is 48, then 48 divided by 4 should equal 12. Let's see. 48 divided by 4. 4 goes into 4 one time. 1 times 4 is 4. Take away a 0. Bring down the 8. 4 goes into 8 2 times. 2 times 4 is 8. Take away a 0. So 12 is my answer. And that's right. That's what we got right here. So 48 divided by 4 equals 12. So that shows that it checks out. N really does equal 48. Let's do one more problem together. 5 equals x divided by 2. Draw the train tracks. Okay, so x divided by 2 means I have an x, but I'm dividing it into two groups. That means I'm dividing it in half. And if I'm dividing it in half, that means half of x equals 5. So what would the whole x equal? I need one whole x. All right. Remember, we can put a 1 in front of our x there. So this is really 1/2 x. And the way that I'm going to get one whole x down here, one whole x, is if I flip this fraction over and multiply. So instead of the 1 over the 2, I'm going to put the 2 over the 1. I'm multiplying by 2 really, but I'm writing it as a fraction. So now 1x times 2, 1 times 2 is 2, so that's 2x. And 2 times 1 is 2. So I have 2x over 2, but 2 divided by 2 is 1. So it works out. And if I multiplied the right side by 2 over 1, I have to multiply the left side by 2 over 1. So 2 over 1 times 5, I can put the 1 on the bottom. So this is 2 times 5 is 10. And 1 times 1 is 1. So 10 divided by 1 is just 10. 10 equals 1x. Or we could take the 1 out of the x because we don't need it, and we could just say x equals 10. Let's check it to make sure it's correct. The original problem was the original problem was 5 equals x divided by 2. Alright, so is it true that x equals 10? Well, if x is 10, we should put 10 here. What is 10 divided by 2? 5. It works, right? X really is 10. So in this video, I've shown you really the long way to solve equations that have division in them. When we flip the fraction over, like the 1 over 4 flips to become 4 over 1, and then we multiply. This is how the math works. And understanding how the math works is really important. But it's really the long way to do it. So I'm going to have another video that shows you the shorter way, but I do want you to understand this longer version so that you understand why you're getting the answer that you're getting. Check out my other video about solving one-step equations with division to see the shorter version.